couple of these to remind you how to graph rational functions, and then your project is you're just doing practice with rational functions, and your group turns in a packet with a lot of completed graphs. So you get to pick your groups. You can have 3 people in a group. We'll get to that after we go through some of this. So these are the steps you should be going through when you graph your rational functions. You always have to factor your numerator and denominator if you can. Find your vertical asymptotes. That's where your denominator equals 0. Remember, that doesn't work. Your horizontal asymptotes, top heavy, bottom heavy, equal. You guys remember that from last year? Yeah, no? Okay. Top heavy, bottom heavy are equal. Bottom heavy, it's always then y equals 0 for your horizontal asymptote. Equal, you divide your leading coefficients. Top heavy gives you a slant for that person.
I remember that little saying, but I don't remember.
Don't remember like doing it, yeah.
We're getting an example, right?
Yeah, of course. What? I am recording.
Can we get copies of that thing?
No.
Oh no, you should like give the video just like
Okay.
Yeah.
Think about that. All right, guys. You also have to graph poles, and then you need to plot points. Guys, biggest thing here, you are doing this without your calculator. Okay, in Algebra 2, most of you had your calculator glued to your hand while graphing. You do not. No. So let's try one, maybe. Well, so this is great. All right, let's do the first one together here. Let's start with this guy. So first step is to factor your numerator and denominator. The reason you want to factor is to see if anything cancels out, because that creates a hole. So you could factor here, but it's not really going to do anything for you, because you'd have x plus 2 and then over x minus 2. Nothing's going to cross out, right? We don't have any common factors. So we can start with our vertical asymptote. Your vertical asymptote is where your denominator equals 0. So what would make your denominator 0? 2. So that means we have a vertical asymptote at x equals 2. Well, you with me? I've seen that look a lot today, so it's, you're not alone. All right, then we're going to think about our horizontal asymptote. So our first step was vertical asymptote. Second step, we're going to do horizontal. So this is what I was talking about with the top heavy, bottom heavy are equal. We're talking about the degree. So the degree of my numerator here would be 1, right? Highest exponent, it's not written, but it's a 1. Degree of the denominator is a 1. So those would be equal, right? Same degree. It's coming back. Yeah. So then all you have to do is divide your leading coefficients. So what's 2 divided by 1? 2. So that is your horizontal asymptote. It's just at y equals 2. So this one was at x equals 2, y equals 2. So I'll graph that. All right. We don't have any holes, we don't have any slant asymptotes, so now we can just sort of start plotting our points. A couple of important points are your x-intercept and your y-intercept. So your y-intercept, we'll do that one first. That happens when x is equal to 0, right? If you're on your y-axis, the x was 0. So what do I get if I plug in a 0 for x? -2, right? So 0, -2, that is a point on my graph. Then your x-intercept, what's happening if we're on the x-axis? What equals 0 this time? Y. So you're trying to figure out where this whole equation equals 0. So if you think about that, I know the y value has to be 0. If I want this to equal 0, this 2x plus 4 over x minus 2, which part of that fraction actually needs to equal 0? The top, yeah. The bottom's where you get your vertical asymptotes from. The top is what gives you your x-intercept. So I'm really solving this. Yes. So what does x have to equal for that to work? -2, right? So I have that point. Okay. I would like you to have at least two points on either side of your vertical asymptote. Do you see how I already have 2 on the left side now? So I can go ahead and draw that shape. Use your asymptotes to help guide it. And then to find your other points, you can just go ahead and make a little table of values. This vertical asymptote was at 2, right? I've already got what I need to the left of it, so what's an x value to the right of it that you might want to use? To the right of 2. 3. Okay. So just plug in a 3. And you are plugging it into this. So your numerator, what's 2 times 3? 6 plus 4, 10 over 3 minus 2. 10 over 1, which is just 10. All right, 310, that's way up here somewhere. What's another number you want to use? 6? You could use 6, you could use 4, you can, I mean, honestly, guys, I don't care, whatever you want to use. Does 6 work out nicely? 6. So that would give me, what, 16 over 4, so just 4. So 6, 4, and then that's enough, you can draw the shape. Most of the time, yes. When you get a slant asymptote, things get a little different, so. Okay, guys, so do you see how I clearly drew the asymptotes? Okay, points are easy to see. It's a nice, neat graph. That's what I'm looking for on your project, okay? All right, let's do one more together. I may have lied. We might have to do 2 more. All right, we'll do this one. This guy next. So this one requires you to remember how to factor. So what does x cubed minus 1 factor into? X minus 1, and then outstanding, guys. X squared plus x plus 1. You knew that, right? So close, yeah. So let's see, it's a cubed minus b cubed. That is a minus b, so that's the same sign. And then it's a squared plus ab plus b squared. If it starts out as a sum, your signs just change. So it's a plus b, a squared minus ab, still plus b squared. The whole same opposite, always positive. Yep, okay, that's a thing. Oh, yes, no. Okay, so let's look at our graph now. So this time, does anything cancel out? What goes away? Okay, that is gone. What does that mean? Think about your types of discontinuity. What happens when they cancel out? That creates a hole. So we know we are going to have a hole, and it's going to happen when x equals 1, right? How are we going to find the y value for that hole? Plug 1 into what's left. So guys, what's left is this x squared plus x plus 1. That is all you have to graph now. So what do I get when I plug a 1 in? 3. So I know right away at 1, 3, I have a hole. Mhm.
So if it was like if there's a hole left here, we can just plug it.
Yep. Yep. And definitely only plug it into what's left. If you try to plug it into the original, you're going to get 0 over 0, which won't work. Okay. All right. Now from here, guys, this one's a little different because it's no longer a fraction that you have to graph. So you don't have to worry about asymptotes of any type. You just have to graph y equals x squared plus x plus 1. How do you graph that? What? It's a parabola. We know that. Do you guys remember anything about your vertex? Negative b over 2a is where you start. So in this case, that would be negative 1 over 2. That gives you the x coordinate of your vertex. And then what do you do with that to find the y coordinate? Plug it in. So again, I'm plugging it into that x squared plus x plus 1. So to find the y, I'm doing negative a half squared plus negative a half plus 1, right? X squared. Yeah. So what is negative 1/2 squared? 1/4. And then I have minus 1/2 and plus 1. So if we found a common denominator for everything, that'd be 1/4 minus 2/4 plus 4/4. What do we get? What? 3/4, yeah. All right, so negative a half, 3/4. That is your vertex. What do you remember about parabolas as far as things being mirrored and symmetry? They're symmetric to the y-axis. So, like, if this is my vertex, if I have a point here, that means I'm going to have the same point on the other side. You are welcome to plug things in. You can plug in -1, -2, whatever you want to. Or you can look at that and go, all right, so this is, do you see how it's 1.5 away on the x? Go 1.5 the other direction, and that will take you up to the same point. It's just not going to be a hole on this side. And then that's enough points for me. You can draw it from there. That's kind of a weird one because it canceled out. That's what you end up with. Okay. We're going to do one more. Let's do... change this one. I changed my mind again. I'm sorry. Alright, we'll do that. X plus 1 over x squared minus x minus 6. Alright, so let's go ahead and factor it. So numerator, we're leaving x plus 1. What does your denominator factor into? X plus 2, yep, x minus 3, good. Okay, does anything cancel out? No. So you don't have any holes to worry about. So then we want to think about our vertical asymptotes. And I have 2 of them this time, don't I? Where are they? 3 and -2, right? Okay, so we've got those drawn in. All right, then to find our horizontal asymptote, is this top heavy, bottom heavy, or equal? bottom heavy? If it's bottom heavy, you don't have any work to do. You just know that it's y equals 0 as your asymptote. Okay. So how many sections of this graph are we going to have this time? You can see how there's going to be 3 different pieces going on. Okay. So let's find a couple of things here. I'll just make one big table this time. I like to find my y-intercept right away. If x is 0, what do I get? I guess I need my equation. Negative 1/6? Yes. So approximately right in there. What about my x-intercept? So if y is 0, what does x have to be to make that work? Yeah, you can use, honestly, you can use either. You can use this, or you can use the factor one. If I want y to equal 0, remember which part of the fraction has to be 0? Just the top. So what would make the top 0? Negative 1. Okay, so that's another point. Guys, that's on your horizontal asymptote, isn't it? That's okay. You can cross your horizontal asymptote. You can do all sorts of weird stuff in the middle. The horizontal asymptote is really just telling you about end behavior. Right? To be 2 points in here, that's not enough to figure out what that shape is doing. So let's plug in at least 1, if not 2 more. Let's plug in 1 for sure, and then maybe also 2. So if I plug in a 1 for x, what do I get? What'd you say, negative 2/6, so negative 1/3? Yeah. So that's there. Let's go ahead and plug in 2 because those are all pretty close together. If we plug in 2, we get what? 3 over negative 3/4? Yeah. Those are not very pretty values, are they? So what's happening here is this is looking kind of like a cubed graph in the middle. The middle's always the trickiest part to see. You have to plug in enough points to decide, is it like a parabolic shape, like a parabola in the middle, up or down, or is it a weird cubed graph going on? So just plug in enough in the middle so that you can see that. Okay. I still have 2 more sections of the graph to do. So if I want to do what's either up here or down here, what x value should I plug in? What's out there? 6 is, what else? 4, 5, yeah. I'm going to plug in 4 just because it's smaller. So let's see, 4 plus 1 is 5 over 6. Is that what we're getting? So that's going to be just above, almost to 1. Alright, let's plug in like a 5 just to see. What do you get when you plug in 5? Three sevenths? Yeah. 6 over 14, 3/7. So that's closer to the x-axis. Do you know what that shape is going to do? Yeah, it's going to follow your asymptotes, okay? So we only have those 2 points, but it's enough to draw it. Okay. And then we still need the left side of our graph too. So what points do you want to use over there? Like -3 and -4 maybe? And what do we get with our -2? 1/3 or -1/3, right? -1/3. Alright, and -4, let's see, so we can So at -3/14. You guys are looking real excited about these fractions. They are not all going to be this ugly, but every once in a while they will be. So what that does is give you that nice little piece over there. Okay. How we doing? All right. Let me pass out for you a couple of things here. So the first thing I'm giving you, this is all the graphs that your group has to do, but everybody has to do one of these packets. So this is like an individual homework grade. The packet itself is a much bigger grade, but that's one that you guys all turn in together that is like super neat and organized and pretty. Okay, this doesn't have to be perfect. This is so that everybody can do every graph. This is not a, okay, I'll do number 1, you do number 2, you do number 3, and then we'll put them together. Everybody has to do every single graph so you get the practice. Okay? Make sense? I told you the PBL wasn't so weird. This is just a little drafting project. Your PBL won't have it until you need. Yes. So yes, today's like a work day. It's not due for a while. All right, guys, and then pick your groups. I'll give your group the big packet and the rubric for it as well. I'd like 3 people in a group. Don't everybody move at once, guys. Here,